Hello students, today's class we are going to discuss shortest distance related problem. It is totally different types of routine problem. So in what way the question is different from routine problem? We should find first equation of shortest distance, very important. Equation of shortest distance and then distance. So find the equation of shortest distance between these two lines. And hence find the shortest distance. This is the nature of the question. So we are given two equations in three-dimensional space: x minus 1 by 2, y plus 3 by 1, z minus 3 by 1. This is the first line. This is the second line. So this geometrically we can understand the first line is L1 passing through a known point A1. The known point, the coordinates of known point can be taken from the given Cartesian form of straight line x minus x1 1, y minus y1 minus 3, z minus z1 3. Similarly, the second line passes through the point x minus x2 0, y minus y2 negative 2, z minus z2 1. And the first line is parallel to B1 vector, that is 2i plus j plus k. Similarly, the second line parallel to the vector B1, B2 vector with component 3i plus j plus 2k. Okay, so remember the B1 vector cross B2 vector, the cross product of the two parallel vector is always along the equation of shortest distance. So the vector along the equation of shortest distance is always B1 vector cross B2 vector. Okay, so it can be decided using determinant form. The first row I, j, k. The second row is component of B1 2 1 1. The third row component of B2 3 1 2. Okay, after expansion B1 vector cross B2 vector 2 minus 1 1i 3 minus 4 minus j and 2 minus 3 minus k. Okay, this is B1 cross B2. This is a vector parallel to equation of shortest distance. Listen, we can have P is an arbitrary point on the first line and Q arbitrary point on the second line. So P an arbitrary point on L1. So for the first line we can introduce constant ratio lambda. So x minus 1 equal to 2 times. Here x minus 1 proportional to 2 means x minus 1 equal to including proportional constant x minus 1 equal to 2 lambda. Y plus 3 is proportional to 1 means y plus 3 equal to proportional constant 1 time lambda. Z minus 3 is proportional to 1 means Z minus 3 equal to 1 time the proportional constant lambda. So x minus 1 equal to 2 lambda, then x equal to 2 lambda plus 1. Y minus 3 equal to 1 lambda, and then y equal to lambda minus 3. Z minus 3 is proportional to lambda, then Z equal to lambda plus 3. This is a point, so use no ordinary bracket. Similarly, Q an arbitrary point on the second line. Now we can assume and x is proportional to 3 mean x equal to avoid the same proportional constant we can use mu. So x equal to 3 times mu. Y plus 2 is proportional to 1. So y plus 2 equal to mu. Then y equal to mu minus 2. Z minus 1 is proportional to 2. Then z minus 1 equal to 2 mu. Then z equal to 2 mu plus 1. Okay. Now using the coordinates of P and Q, we can find the direction ratio of the shortest equation, the line of shortest equation, that is PQ. So line of shortest distance. This is assumption. The direction ratio of the equation of shortest distance, the difference x2 minus x1 or x1 minus x2, the difference of these two, 2 lambda minus 3 mu 1 minus 0 plus 1, lambda minus mu minus 3 minus or minus 2 plus 2, so minus 1, and lambda minus 2 mu and 3 minus 1 plus 2. Okay. So this is direction ratio PQ. Listen, the point to be noted, very important. The equation of shortest distance PQ is parallel to B1 vector cross B2 vector. So, and PQ is parallel to B1 vector cross B2 vector mean the direction ratio of PQ and direction ratio of B1 cross B2 are in proportion. That is, the direction ratio of PQ with respect to x-axis 2 lambda minus 3 mu, 2 lambda minus 3 mu plus 1 must be proportional to x component of B1 cross B2. X component of B1 cross B2, that is 1. Similarly, the y component of the vector PQ, that is direction ratio lambda minus mu minus 1 is proportional to negative 1. Lambda minus, for z component, lambda minus 2 mu plus 2 is proportional to negative 1. We can do one thing, multiply all the three ratio by negative 1, then this negative 1 minus 2 lambda plus 3 mu minus 1. We multiply with negative 1, lambda minus mu minus 1. The third ratio in the negative 1, lambda minus 2 mu plus 2. Okay. Taking first two, you can get one result in terms of lambda and mu. 2 lambda minus lambda 1 lambda, 3 mu minus or minus mu 4 mu, minus 1 and minus 1 0 equal to 0. Another result, you can compare these two. Lambda minus lambda 0, minus mu, this negative 2 mu, this side plus mu, and minus 1 minus or minus minus 3 equal to 0. This implies mu equal to 3, and substituting mu equal to 3, mu equal to 3, 4 times mu 12, so lambda equal to minus 12. Once again, minus 2 lambda, we bring okay, this minus lambda, I think we need some correction. Minus 2 lambda minus 3 lambda. 3 mu minus or minus 4k. Now what to do? Lambda cannot be negative 12. So mu equal to 3 mean 3 times lambda equal to 3, negative 9. Mu equal to 3. So 4 times. So 3 lambda equal to 4 mu. Then 4 into 3, 12. Then lambda equal to 4. Okay. So we have got mu equal to 3 and lambda equal to 4. For known values of mu and lambda, now we are in position to get the coordinates of P and Q. What is coordinates of P and Q? Substitute here P. Lambda equal to 4. 2 times 4, 8. 8 plus 1, 9. Lambda equal to 4. 4 minus 3, 1. Lambda equal to 4. 4 plus 3, 7. Okay. Then we will come to Q in term of mu. Mu equal to 3. 3 times 3, 9. And 3 minus 2, 1. And 2 mu plus 1. 2 mu plus 1. What's the value? 2 into mu and 6 plus 1, 7. Listen, here P and Q same. So this is point of intersection. So this is not skew line and intersecting line. So intersecting line through the point of intersection, and so this cannot be equation of shortest distance. Here shortest distance equal to, for this particular question, shortest distance equal to 0. Then line passing through the point of intersection and parallel to B1 cross B2. Then we can have R vector equal to the point of intersection 9i plus j plus 7k. R vector equal to 9i plus j plus 7k plus some scalar. We can avoid lambda mu, some t time b1 cross b2 vector I minus j minus k. Listen, because of the coincident point, this become intersecting line. So the line through the intersecting line and parallel to B1 cross B2 is perpendicular to both two lines. Intersecting line perpendicular to both. Okay. Sometime in case the coordinates of P and Q different coordinates mean, using 2 points formula we can find the equation of shortest distance. Again using 2 points formula we can find the distance, that is shortest distance. This is a method, and my dear student, and go through and practice more problem. But luckily this question P and Q coincident points, so this is intersecting line. In many, if it is really skew lines mean non-parallel and non-intersecting. So for non-intersecting line the coordinates of P and coordinates of Q won't be same. So P will not coincide with the Q. So whenever the coordinates of P and Q are different skew lines, and using 2 points formula we can find the equation of the line through the shortest distance, equation of shortest distance using the formula x2 minus x1 by x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1. Then what is the distance? Distance formula root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square is routine type of problems. Make use of these videos and practice more and more videos and benefit more. Thank you, students.